Hello friends, welcome back to my channel. My name is Vinay. In the previous few videos we did discuss questions from relations and functions appeared in KCET previous year question papers. In this video we shall discuss the same chapter questions from previous year KCET 2021. There are 4 questions friends. Let's get into solving questions quickly one by one. The first question goes like this. Now, domain of the function f of x is equal to x divided by 1 minus modulus of x is. Now, friends, a rational function is given to us. So, for a rational function, the method of finding domain is finding the domain of the numerator function and denominator function separately and then find the intersection. That is the easiest way of solving this. Now, let us see what kind of functions we have in the numerator and denominator. In the numerator, friends, we have x, and in the denominator we have 1 minus modulus of x. The numerator function x is a polynomial function, and for any polynomial function, keep it in mind friends, for any polynomial function the domain is set of all real numbers. So clearly for the numerator function we have domain as set of all real numbers. Similarly in the denominator we have 1 minus of modulus of x. So for modulus of x, the domain is again set of all real numbers. If you add, subtract, divide anything, any real number to this modulus function, the domain will never change. That means if you have modulus of x plus 1, then also the domain is set of all real numbers. If you have modulus of x divided by 5, then also the domain is set of all real numbers. So here we have in the numerator friends x, for this domain is set of all real numbers. In the denominator we have 1 minus modulus of x. For modulus of x, the domain is set of all real numbers. So 1 minus modulus of x domain is also set of all real numbers. But for the given problem, this function is in the denominator. So we need to check out for what values of x 1 minus modulus of x is 0, because in the denominator if we get 0, the whole term will become not defined, function is not defined. So let us verify that friends here. Now 1 minus modulus of x is equal to 0. If it is equal to 0, then at those points of x the function is not defined. So we have here 1 is equal to modulus of x. Now for what values of x modulus of x can be equal to 1? There exist only 2 values. One is x is equal to minus 1. If you put minus 1 here, modulus of minus 1 is equal to 1. So LHS is RHS. And one more possibility for this equation is 1. That is 1 is equal to 1. So in these for these two values of x, minus 1 and plus 1, 1 minus modulus of x will be equal to 0. So we know it should not be equal to 0. Then what should be the domain of this denominator function now? Now 1 minus modulus of x domain is set of all real numbers. Because it is in the denominator, we have to exclude 2 values, minus 1 plus 1. Now clearly in this case, in the numerator you have set of all real numbers. In the denominator, set of all real numbers excluding minus 1 comma 1. So we need to go with the intersection of these two. Now the second set here is the subset of first set. First set is the superset, real number set. Here 2 values are excluded. That means this becomes the subset. So we know that intersection of a superset and subset is a subset. So for this, the domain is set of all real numbers excluding minus 1 comma 1. This is our answer, friends. Here only two values we need to exclude, that is minus 1 and 1. So we should be very careful while choosing our answer. See here in option A we have r minus closed interval minus 1 comma 1. What is the meaning of this closed interval minus 1 comma 1? X takes the values from minus 1 to plus 1, all real numbers from minus 1 to 1 plus 1. But here what we are excluding only two particular values, that is minus 1 and plus 1. So option A is not our answer. Option B obviously not, because here we have open interval minus infinity to 1. Here in option C we have open interval minus infinity to 1 union 0 comma 1 open interval. Now we have here set of all real numbers excluding only 2 points, so option C also not possible. So option D is our solution, friends. Here we had a rational function. Even though if you have these any four operation between two functions, friends, addition, subtraction, multiplication, division, between two functions or between three functions, you have f of x plus g of x, or f of x minus g of x plus h of x. In these cases, when these operations are applied between two functions, then the domain of the whole function is always intersection of the domain of these two. That is what we have applied here also, friends. So whenever you see f plus g, f minus g, like this, friends, f plus g, f minus g, f into g, or even f divided by g, to find the domain we need to find the domain of both the functions separately, then take the intersection of those two. This is how we can solve these kind of problems to find the domain. Okay, friends, let's move on to the next one. Here a real function is given, f from r to r, defined by a piecewise function 2x, and this 2x function, for this 2x function domain is set of all or x is greater than 3, that is open interval 3 to infinity. So for all these values the function is 2x, and x square for 1 to 3 where 3 is included. For this interval, the function is x square, and for x is less than or equal to 1, that is minus infinity to 1 is included. For this interval the function value is, or function is 3x. Now very simple question, friends, but what we need to keep it in mind, the domain of the three different piecewise functions. Accordingly we need to use the function to find the value of the given expression. What is the expression? F of minus 2 plus f of 3 plus f of 4. Very simple one. Here we have to go with x value. X is minus 2, x is 3, and here x is 4. Now we need to find the value of the function at x is equal to minus 2. So x is equal to minus 2 falls in this interval minus infinity to 1. So to find the value of this function at minus 2, we choose x is equal to 3x. F of x is equal to 3x. That gives you 3 into minus 2 plus f of 3 we need to find now. Where 3 we have, see where equal condition is there, we have equal condition in the middle function, that is 1 to 3, the function is defined as x square. So at x is equal to 3, the function is x square. So we will go with here and take x is equal to 3, and 3 square we have, plus f of 4. 4 belongs to this interval 3 to infinity. So for that the function is 2x. So we will take 2 into 4. Now the very simple question, friends, minus 6 plus 9 plus 8. 9 plus 8, 17. 17 minus 6, 11. So our answer is option D for this question. So one thing we have to keep it in mind in this kind of question, that is piecewise function, the domain of the function, how it is distributed among the given piecewise functions. Then finding the values, deciding the domain, everything will become easy, even though for deciding the range also. Okay friends, let's move on to the next one. Here a set is given to us. Let A is equal to set of all x such that x belongs to R. X is not a positive integer. So now x belongs to all real numbers, excluding positive integers that can also be taken as natural numbers. So they are excluding natural numbers 1, 2, 3, 4, 5, 6. But between 1 and 2 there are infinitely many real numbers that we should not exclude from this set. Only natural numbers we have to exclude. Alright, so here the set, what they are talking about is set of all real numbers. What you have to exclude? Natural numbers. This is what they have given as set A. Okay, now they have defined a function from f from A to R. A is this set, R minus set of all natural number, R is set of all real numbers. The defined function is this, f of x is equal to 2x divided by x minus 1. Then f is, we have to verify it for injectivity and surjectivity. Injectivity and surjectivity means 1 function and onto function. For 1 function, the method of verification is taking f of x is equal to f of y for the given function and prove x is equal to y. This is the basic method we know how to solve for 1. One more method is proving this function is decreasing, strictly decreasing actually, or strictly increasing. Keep it in mind friends, any function, if it is strictly decreasing, function is 1, as well as if it is strictly increasing, then also function is 1. So we know that f dash of x, that means differentiation of the given function value, if it is greater than 0 but not equal to 0, if it is greater than 0, our conclusion is the function is strictly increasing. Similarly, if f dash of x is less than 0, our conclusion is the function is strictly decreasing. In both the cases, the function must be 1. Now let us verify here. You can go by the method already you know. Otherwise, we can go by differentiation. Okay, let us find it by differentiation friends. Let us find f dash of x here. Differentiating the function f dash of x, the function is in the form u by v, u dash v minus uv dash divided by v square. That is the formula we have. U dash means numerator differentiation, 2x differentiation is 2, and the denominator function we have to keep as it is, minus, keep the numerator function as it is, denominator function differentiation, x minus 1 differentiation is 1 minus 0, that is nothing but 1. 1 differentiation is 0, x differentiation is 1, divided by x minus 1 whole square. So see friends, let us simplify the numerator here. Let us check out what is the value of this function. Then we can conclude, if it is greater than 0, strictly increasing, less than 0, strictly decreasing. In both the cases, the function is 1. So multiply 2 first, 2x minus 2 minus 2x whole divided by x minus 1 whole square. Minus 2x plus 2x will get cancelled. Minus 2 divided by x minus 1 whole square. Now friends, for this function, is this function always negative for any real numbers or always positive for any real numbers? Just think once. In the numerator you have a constant that will never change. the value. In the denominator we have x minus 1 whole square. As the power is 2 whole square, denominator function is always positive. So in the numerator you have a negative number. For any value of x, the denominator is positive. Negative number divided by positive number is always negative. It cannot be 0 also. So by looking at this function, what we can conclude, the value of this function is less than 0. So clearly we got here, friends, f dash of x less than 0. So the function is monotonically decreasing, monotonically decreasing. So if a function is monotonically decreasing, that is strictly decreasing, our conclusion is f is 1 1. F is 1 1. So we have verified for 1 1. This function is 1 1 because this function is strictly decreasing. Let us verify onto also. To verify onto, what is the method we have? Y is equal to, what do you have? Let me check the function, 2x divided by x minus 1, 2x divided by x minus 1. To find the surjectivity of the function, first we have to express x in terms of y. Okay, now the function is in terms of y in terms of x. Let us express this as x in terms of y. Shift this into left hand side. Carefully look at these steps, friends. What we need to do, and multiply y to these two, x into y, xy minus 1 into y equals 2x. Now we need to express x in terms of y. In that case, we need to group all x terms together, and remaining we need to shift it into other side of the equation. So here what we are going to do, we'll keep xy here. In the right hand side we have 2x, shift that into left hand side, it will become minus 2x is equal to, here minus y is there, no, here no x term, shift this into right hand side. Now here take x common in the left hand side. What will you get? Y minus 2 is equal to y. Now we got a function x is equal to y divided by y minus 2. Now this y divided by y minus 2 is nothing but x. Now we need to verify what are the values of x, friends. It can be any real number excluding natural numbers. Okay, and what are the values of y? The range is given here is set of all real numbers, or we can say codomain given in the question. Now we need to verify here, if for every value of y there exists x. That is what we need to verify. Clearly the denominator is y minus 2. If you put y is equal to 2, what is your conclusion? So clearly for y is equal to 2, what do you have? X is equal to 2 divided by 2 minus 2, 2 divided by 0, that is not defined. So for y is equal to 2, because y is every real number, it lies in codomain. For this value there exists no x, x is not defined. So for y is equal to 2, there exists no value of x in the domain. So we know that at least one element in the codomain do not have the pre-image. Then our conclusion is f is not onto. Okay, friends. So this given function is 1 1 but not onto. That means this given function is injective but not surjective. Clearly, our option A is the right answer. Okay, friends, let's move on to the next one. Again, we have a question on domain to find the domain of the function. Very simple one, friends. Again, a rational function, numerator and denominator. In the numerator 1, always keep it in mind, 1 is a real number. And every real number can be expressed as a polynomial function. So every real number is a polynomial function. That is called a constant function. How we can conclude it is a polynomial function? Let us take one example. You have a number 2. Can I write it as 2 into x to the power 0? Because x to the power 0 is a polynomial. 2x to the power 0 is a polynomial function. So 2 can be expressed as 2 into x to the power 0. Similarly, here 1 can be expressed as 1 into x to the power 0. So it become a polynomial function. So any constant function is a polynomial function. And also already we have discussed in the previous question, for any polynomial function, friends, the domain is set of all real numbers. So it is very clear for the numerator function 1, the domain is set of all real numbers. And for the denominator, obviously we are going to get any subset of the set of all real numbers, because for if denominator is equal to 0, the function is not defined. So here what we can do, we'll find the domain of the denominator and no need to find the intersection. Already, as we have discussed, addition, subtraction, multiplication, division is there of two functions. Then the domain is domain of both intersection of both the functions. Okay, here let us check out in the denominator what you have. In the denominator we have root function. For under root function, friends, under root x, what is the domain? For this x, can you take negative numbers? Can you take 0? Can you take positive numbers? That's what the domain is all about. Can you take 0? Yes. Root 0 is 0. Positive number, root of any positive real number is real number. But root of negative real number is imaginary. So the domain of this function root x is set of all non-negative real numbers. Okay. Now, if root x is in the denominator, root x is in the denominator, then for root x, the domain is open interval 0 to infinity. Why, friends? Just because it is in the denominator root x, if you put 0 there, then root 0 is 0. Any real number divided by 0 is not defined. So if only root x function is there, the domain is set of all non-negative real numbers. If root x there in the denominator, for the same function, the domain is set of all positive real numbers. So in the given question, under root function is there in the denominator. So whatever the function you have under root, that must be greater than 0. If the value of that function is equal to 0, then done. You will get not defined. Now let us take this function. What the function they have given? Greatest integer function x square minus greatest integer function x minus 6 is equal to 0. I have taken is equal to 0. That means what? It should not be equal to 0. But what is our domain for this function? The domain is greater than 0. So we will go with this inequality greater than 0. We will find greatest integer function x value. Here we have a quadratic polynomial in greatest integer function. Let us split the middle term, friends. What you have here, 6 and 1. So you can split the middle term as minus 3 plus 2. Okay, friends, let us write this as greatest integer function x square minus 3 into greatest integer function x plus 2 into greatest integer function x minus 6 is greater than 0. Now take out common greatest integer function x square, then greatest integer function x minus 3, here plus 2 is common, greatest integer function x minus 3 greater than 0. So we got two factors here, greatest integer function x minus 3 and one more greatest integer function x, sorry, it is not x square, it is x plus 2 greater than 0. Now how to decide? For what values of greatest integer function x this inequality is true? The product of these two factors must be greater than 0. For this, friends, we will take it as an equation first. Now we will consider this as an equation. Carefully listen. Minus 3 greatest integer function x plus 2. We'll make it an equation. We will find the critical points. That means values of x making it equal to 0. Modulus of x is equal to 3 and modulo greatest integer function x is equal to 3 or minus 2. Now put it on the number line, friends. Let us verify. Minus infinity to plus infinity and minus 2 plus 3. Now the intervals are minus infinity to minus 2, that is the first interval, and the next interval is minus 2 to 3, and the next interval is 3 to infinity. Now to verify for which interval is the domain of this function, we have to put any one value from each interval in the given or in the inequality we got. Now here we will go with put any value between minus infinity and minus 2. Take minus 3 here for greatest integer function x. If you take minus 3, minus 3 minus 3, minus 6 into here minus 1, it is 6, which is greater than 0. So this is one of the domain we have because the value is greater than 0. Okay, and you go with any value between minus 2 and 3 gives 0. 0 minus 3 you are going to get minus 3. 0 plus 2 you are going to get 2, which is minus 6, which is less than 0. So this cannot be the domain. And one more last set we have, 3 to infinity give 4. 4 minus 1 is minus 3 is 1. 4 plus 2 is 6. And again it is positive 6, which is greater than 0. This is possible. So the possible values of greatest integer function x is less than minus 2 or possible value, one more set of possible values of greatest integer function is greater than 3. So let us verify, friends. Less than 2, and we know the values of, we need to find the values of x for this. X can be equal to, can you take minus 2? Minus 2 is not possible, friends, because if you put minus 2 here, greatest integer function minus 2 is minus 2 itself. We need a value less than minus 2. So we need to consider minus 2.3. Is it possible? As minus 2.3 value is 3 minus 3. Similarly, any value less than minus 2 is possible. For any value less than minus 2, less than minus 2 and greater than or equal to minus 3, the greatest integer function value is minus 3. So greatest integer function value is minus 3 for these these values. So x belongs to here, x belongs to minus infinity to minus 2. In this case, I can take any value between minus infinity and minus 2, and the greatest integer function value is minus 3, or you may get minus 4, minus 5, as it goes on up to negative infinity. Similarly, here we have one more condition, friends. X is greatest integer function x is greater than 3. Be very careful. Here, if you put 3.1, what is greatest integer function 3.1 value is equal to 3. So x cannot be 3.1. Can you take 3.9? The greatest integer function 3.9 value is 3. So you must start from 4. Greatest integer function 4 value is 4. Any value greater than 4, the value is 4. Any value greater than 5.1 I can take, and the value of the greatest integer function will be 5 here, and in this case it is 4. So we are going to get 4, 5, these values we are going to get which are greater than 3. So be very careful, friends. We are finding the values of x. Value of x cannot be less than 4, cannot be less than 4. It is not possible, because if we take less than 4, the greatest integer function value will become 3, which is not greater than 3. So one more interval, friends, here we are going to get, that is x belongs to, it starts from 4 is included, friends, to infinity. Why 4 is included? We know that greatest integer function 4 value is 4. Okay, so by taking the union of these two, here we have a single function, friends. We are going to take the union. We are going to take the union of this. The union of this is minus infinity minus 2 union 4 to infinity. So this is the domain of the denominator. Clearly this set is subset of the set of all real numbers. In the for the numerator, what is the domain? We have set of all real numbers, and for the denominator, what is the domain we have? Open interval minus infinity to 2 minus 2 union open interval 4 to infinity, where 4 is included. And for the numerator, the domain is set of all real numbers, which is the superset, and which is the subset. The intersection of these two will be the subsets itself. So our option for this question, friends, is option A, that is open interval minus infinity to minus 2 union 4 to open interval 4 to infinity, 4 is included. Friends, if you like this explanation, please like, share and subscribe. Hit the bell icon for the further notification. If you feel any concept you want me to explain, please do comment in the comment box. I will try to make the video on those concepts which you require. Thank you very much.